So some factoring polynomial problems in front of you, and this is a trinomial, and it says factor the following expression. And whenever it says factor the following expression, remember, and you have a trinomial, it's the product of, usually the product of two binomials. So we are going to focus on this 32. And that 32, you're going to have to pick two numbers that multiply to 32 and that add and subtract to 12. So I'm going to put in the way I get the ball rolling in the factors is 32 times 1, obviously. And 32 times 1 could make a 33 if you add them. And if you subtract them, it can make a 31. That's not going to make a 12. So we're not going to do that. Then it's 16 times 2. So 16 times 2 can make an 18, or it can make a 14 if you subtract them, not a 12. So now I'm going to go to 8 times 4. 8 times 4 is 32, and then 8 plus 4 is 12. Oh, we can use that. So I'm going to say that this is H, this is H, obviously, and I'm going to put the 8 in and the 4 in. And you notice that I do not put the signs in of the numbers yet. If I have to multiply to a positive number, there are two ways. Positive times a positive, and negative times a negative. So it either has to be positive times a positive or negative times a negative. If I put positive and positive here, that would give me all positives, even a positive 12. Since this is a negative 12, I'm going to go with the negative and a negative. And if I do distributive property, h times h would be h squared. H times negative 4 would be negative 4h, and negative 8 times h would be negative 8h, and negative times negative right here would be a positive 32. In the middle, I would have negative 4h minus 8h, and that would be negative 12. So these are your answers. If you put both positives, it would be a positive 12h. Going down to factor right now, and you could press pause if you would like to try this problem and then see what the answers are. So press pause now if you would like to do that. I'll give you a couple of seconds. Press pause and do the problem. Okay, so I am going to go ahead and take a look at 40 times 1. I'm going to write some factors down. 40 times 1 could make a 41 or a 39, so that's not going to work. 20 times 2, that could equal 40 as well, but it will not add or subtract to 3 because that would add to 22 or subtract to an 18. So now I'm going to go 10 times 4. Okay, 10 times 4 is 14. And then, all right, so we have that we don't have it. This is 6 if you subtract them. So what else goes into 40? Well, 8 times 5. If you take a look at 8 times 5, 8, 9, 10, 11, 12, 13, if you add them, or 8 minus 5 is negative 3. 8 minus 5 is 3. Negative 8 plus 5 could be negative 3. So that could be my answer. That could be my factors. But I'm just going to put T and T down. Those are my factors, definitely. But we have to put some signs in. Remember, it has to multiply to a negative. So that means 1 has to be positive and 1 has to be negative to multiply to a negative 40. It has to add or subtract to a negative 3. So I'm going to put the negative next to the larger number. So I'm just going to do negative 8 times 5 just quickly, and that equals negative 40. Negative 8 plus 5, you can check it out, that equals negative 3. So we have the two that we need, and that is the answer completely. If you could check it out by doing the full complete distributive property, or you could do it just the way I did. Negative 8 times 5 is negative 40. Negative 8 plus 5 is negative 3. We're good, we're good. And that is it. Going on to the next page. Multiply the binomials, and just really step by step, remember this is distributive property. We have x times x, so that's the first thing that we do, and I'm going to put that down as x squared, obviously. And the next thing that you have to multiply that x by is the 3. Right? So x times 3, and this is positive x times a positive 3, and that is 3x. The next is, first off, the distributive property is all finished for the x. Now you have to move over to the negative 7. So negative 7 times x is negative 7x. And the last is negative 7 times 3 is negative 21. As a final answer here, and again, just make sure that you are adding correctly x squared, and then you have to combine like terms, and the like terms are right in the middle. Plus, it's a positive 3. It's a positive 3 minus 7. And you enter, and it is a negative 4x. Just to make sure with your calculator. And you bring down the negative 21, and that is your final answer. Very easy, very nice. Number 4. If you think you could do this, go ahead, copy that question down, and give it a try. I'm going to ask you to press pause, and then see if you could factor out the greatest common factor. Go ahead, see if you can do that. Now, press pause. So, hopefully if you try this on your own, you could realize right now that you have one set of parentheses. Even though this is a trinomial, it's not like this one that, oops, like in the first, it's h squared minus 12h plus 32. That's the product of two binomials. This one is not going to be. It says factor using GCF, and what that usually tells you is that one of these, like, you're going to have to take out, this is one set of parentheses, you're going to have to take out a greatest common factor. And remember, every single time I do this, I take a look at all the numbers first, and I'm going to put, all right, so that, see, 8, 16, 24. All right, so 8 doesn't go into, 8 goes into 8, 8 goes into 16, but 8 doesn't go into 28. So you can't pull the 8 out. But I think 4 can work because 4 goes into 8, 4 goes into 28, and 4 goes into 16. So that is the greatest common factor. Now, do all of them have an X? Nope, can't pull it out. Do all of them have a Y? Yes, yes, yes. So that can be pulled out. So the greatest common factor of these three terms is 4y. All right, so I pulled that out. Now we can do distributive property kind of like in reverse in your head. All right, so 4 times what equals 16? That is 4. There is no x here, so this x has to be brought down. And what times y equals the y squared? That's y. So if you did 4 times 4, that's 16. X has to come down because there is no x here. Y times y equals y squared. You would get this. So 4 times what equals 28? That is 7. There is no x that I pulled out, so I'm going to bring the x down. And then to see this y, it's okay. You don't have to put anything there. And that is it. If you multiplied it, you would get exactly this. 4 times what equals 8y. 4y times what equals 8y. And that is a 2. That is your final answer. If you did distributive property right here, you would get this top back, and that's how you know you got it correct. All right, number 5. What is the greatest common factor of the expression? It's just asking for the greatest common factor. Press pause and try it on your own. So the best way I could tell you to do this is take it one step at a time. 42 and 63. What's the greatest common factor that goes into those numbers? Um, so just thinking about greatest common factor, it has to be the greatest number. So I am going to, let's see, I usually start with the 42. Does 42 go into 63? No. Then I would take half of 42, and half of 42, you could just go ahead and use your calculator. Half of 42 is 21. Does 21 go into 63? I'm going to figure it out right now using the calculator. Yes, it does. All right, so 21 is the greatest common factor, and that's what you do with your calculator. You put that, like, and if you were figuring out this whole thing, you would put set of parentheses. For this one, it's just asking for the greatest common factor, so that's all we're going to do. So it's 21, all right, goes into both those numbers. R and R squared and R to the third. The exponent that's the least comes out because R squared goes into R squared and R squared goes into the R to the third as well. If you don't believe me, R squared times R is R to the third. So yes, R squared is used to get R to the third. So that means it is a factor. It is the greatest common factor that you can pull out. All right, now t to the third and t to the fifth. T to the third is the greatest common factor between those two. T to the third is a factor. T to the third times t squared equals t to the fifth. And that's it. This is the greatest common factor. That is the answer. Greatest common factor. Identify the greatest common factor again of the polynomial. So we're going to do this the same exact way. Take a look at the numbers and see if you could do this on your own. You could press pause now. Okay. So again, I'm sorry, this is the same as number 4. All right, so this is the same as number 4. You don't have to do it. We'll skip this right now and factor out the greatest common factor and simplify the polynomial. So a little bit easier. We're going to underline all the numbers. If you really want to try it on your own, just go ahead and press pause and try to do it, and then unpause it, and then my answers will be there. So you can press pause now. I'll give you a second to do that right now. Okay, so the greatest common factor of 10 30 and 15. You would say 10. No, 10 doesn't go into 15. So 5. And I'm going to leave a little space because I noticed that all of them, all of the terms have y in it. So that means y to the fifth, y to the third, and y. Um, so the greatest common factor of those three is y. So now we could do distributive property inverse. What times 5 equals 10? That's 2. Y times what equals y to the fifth? Y to the fourth. All right. So what times 5 equals 30? 6. What times y equals y to the third? Y to the second. Remember, you add exponents when you are multiplying. 5 times what equals negative 15? Negative 3. And that's just y, and we already pulled that y out, so I'm going to leave that as my final answer. Number 8 is just factoring, and this is a trinomial. So we have already, we're just going to set up two sets of parentheses, just like this. And the first thing that I usually do, you know the first thing I do, sometimes I put x times x down because I see x squared and I know it's there. Then I look at this number and I start putting my factors down. Remember, this is a 1. So you have to pick two numbers that multiply to 20 and that add or subtract to 1. Now, just let me say, like, when you really get good at this and you see this as a low number, like 1, that means the numbers are consecutive. So if I put down 20 times 1, those numbers are not consecutive. They're not in a they're not right in a row. I can make 21 or 19 out of this. I need 1. So that means I need numbers that are right next to each number, right next to each other, and they're consecutive. So that means I know that 5 times 4 is what is going to work here. All right, I could have put 10 times 2, but those aren't consecutive numbers. I can make a 12 or an 8 out of it. I need a 1. So I need to multiply to a negative. So that means one has to be positive and one has to be negative. Since this has to come out to be a positive 1, the positive goes with a larger number and the negative will go with the smaller. If you do distributive property, you'll see that it works out. 5 minus 4 is 1. 5 times negative 4 is negative 20. Going to the next one, again, I am going to put my my parentheses down, and this is again another trinomial, and you know that it's something that you're going to have to factor, and I'm going to put the same thing here. If you want to go ahead and do number 9 and 10, see if you can do those. You can press pause now and unpause it when you're finished with both problems. Press pause now. So I'm going to put x and x here, right? And then I'm going to look at this number. I have to multiply to 56 and add or subtract to 15. So I know that 56 times 1. You notice that 15 right there, the numbers are not consecutive. Okay, so that's how I know that. All right, so let's see. The numbers might be further apart than I'm thinking. They are 15. The numbers will be 15 apart, or not 15 apart. They have to either add or subtract to 15. They could be consecutive, but remember, if you're multiplying to a positive, they could be consecutive. You could multiply by positive, or negative or negative. But I know that 56 and 1 are it's not going to make 15 if you add or subtract them. So now 56, I would just divide it by 2. All right, that is 28. So 28 times 2 is 56, but that's not going to make me 15. So 56 divided by 4. I am going through this like I do not know multiplication. All right. So 14 times 4. Is that going to make me 15? No, it's not. It's going to make me 18 or 10. So now I am going to go 56 divided by 6. That does not work. 56 divided by 8. 7. So 8 times 7, yeah, they're consecutive. So that does make 15 if I add them together. But I have to, if I put a plus and a plus here, I'm not going to get negative 15. I have to have a negative and a negative. All right, negative 8 minus 7. Think about it. Negative 8 minus 7. That is negative 15. That's exactly what I got. And that is my final answer. So it could be consecutive if it's not a small number in the middle, but if it is a small number, you know that it's definitely consecutive. All right, so now we have x and x. Factor again. 14, I have to multiply to the 14, and I have to add and subtract, or to add or subtract to a 9. So I put 14 and 1 down. No, 7 and 2. Oh, okay. 7 and 2, that adds to a 9. And by the way, see, when it's all addition, positives like this, just put the positives down. Do yourself a favor. And 7 and 2 is your answer. All right, and that covers the homework. And covering that, factoring polynomials. Just remember, you see a trinomial like that, like these two, you're you're going to put two sets of parentheses down, because the trinomials like these, they are the factor of two binomials. If you see it says factor out the greatest common factor, that means you're going to have one set of parentheses, right? And then you're going to factor out the greatest common factor just like we have here, and then do distributive property in reverse. Don't get confused with that. I used to get confused with it myself. And it says, just read the questions 5 and 6. They ask for the greatest common factor only, right? So just make sure you're basically going through, and 6 was the same as 4. You're basically going through and just taking out the greatest common factor and forgetting about the parentheses for now, because it's only asking for the greatest common factor. All right, the GCF. If it only asks for that, that's all you have to give. All right, going to number 4, you notice that it says factor using the greatest common factor. You know that there's one set of parentheses, taking a look at this and say, all right, I have to look at the numbers first. Let's look at those numbers first. And 4 goes into all of them. I would say 8 right away, but 8 doesn't go into 28. All right, and you know how to do number 3, and you know how to do number 2, hopefully. And factoring out a trinomial, you set up the two parentheses just like this. Look for factors of 32 that multiply to 32 and add or subtract to 12. All right, and that will cover that. See you next time.